Hello viewers, welcome to lecture 6 on integral calculus. Today we will do some more problems on differential equations. So, let us start with question number 1. Let f be a differentiable function on R such that f of 1 equal to 1 if the y-intercept of the tangent at any point p x y on the curve y equal to f x is equal to the cube of the abscissa of P, then find the value of f at minus 3. So, here we are given some condition, we have to first form a differential equation and then solve it. So, we know that slope of tangent at p x comma y is given by dy by dx. So, therefore, equation of the tangent at p x y is given by y minus small y equal to the slope is dy dx times capital X minus x. So, here because the point is given as small x comma y, we have used capital X and capital Y to write the equation of the line. So, putting x equal to 0, capital X equal to 0, we get capital Y is small y minus x dy dx. So, this gives the y-intercept. And abscissa of this point p x y is x. So, what is given is the y-intercept y minus x dy dx, this is equal to x cube. So, this can be rewritten as dy dx minus 1 by x times y is equal to minus x square. So, we divide the equation by minus x to get this. Now, this is a linear first order ODE. So, we know to solve this, we need to find integrating factor equal to exponential of integral of p x dx, so minus 1 by x dx, which is e to the power minus log x which is equal to 1 by x. So, the solution is y times integrating factor 1 by x is equal to integral of 1 by x times g of x is minus x square dx. So, that is minus x dx. So, minus x square by 2 plus c. This implies y is equal to c x minus x cube by 2. Now, we are given that f of 1 equal to 1. So, when x equal to 1, y equal to 1, this implies 1 is equal to c minus 1 by 2, which implies c is equal to 3 by 2. So, therefore, y is given by y, which is f of x, is 3 by 2 x minus x cube by 2. Now, we can calculate f at minus 3 equal to 3 by 2 into minus 3 minus 3 cubed by 2, which is equal to minus 9 by 2 plus 27 by 2. So, that gives 9. So, this is the answer to this problem. Okay, now let us move to question number 2. So, question 2 says that let gamma denote a curve y equal to yx, which is in the first quadrant and let the point 1 comma 0 lie on it. Now, let the tangent to gamma at a point P intersect the y axis at point y p. If p y p has length 1 for each point P on gamma, then which of the following options is or are correct? So, if you see the options, then option A and option C are negative of each other, and we are given that the curve should lie in the first quadrant. So, y should be bigger than 0. So, only one of the two options A and C can be correct. Of course, it may happen that both are wrong. So, let P be the point whose coordinates are x comma y, then in the first problem we have derived the y-intercept at a general point on a curve. So, we know that y p is the point 0 comma y minus x dy dx. So, by the previous problem. Now, what is given is given the length pyp is equal to 1. So, we get 1 is equal to pyp square, and the distance of pyp squared will be x square plus x times dy dx whole square. So, this gives dy dx square is equal to 1 minus x square by x square. Now, since we have square of dy dx, this has to be bigger than or equal to 0. This implies that x square must be less than equal to 1, which means that x has to be between minus 1 and 1. So, therefore, we will get that dy dx at any point on the curve is equal to square root of 1 minus x square divided by x with plus or minus signs. So, this is because gamma lies in the first quadrant, we have x bigger than 0. So, x is positive, x will lie in the open interval 0 to 1. Now, here we have to be careful and see which sign is valid. Note that it may happen that this dy dx is with positive sign for some x in the interval 0 1, and it may be negative for some x, but we will show that that is not possible. Why is that? Because if dy dx is greater than 0 for some x 1 in 0 1 and dy dx is negative for some x 2 in 0 1, then by the continuity dy dx must be 0 at some x in 0 1. However, dy dx square we got is 1 minus x square by x square. This is non-zero for all x in the open interval 0 1. So, therefore, either dy dx is equal to square root of 1 minus x square by x, or dy dx equal to minus of square root of 1 minus x square by x for all x in the interval 0 1. So, now if dy dx is greater than 0 in 0 1, then we know that the derivative greater than 0 implies that y x is an increasing function in the interval 0 1. Also, it is given that y at 1 is equal to 0, because 1 comma 0 lies on gamma. So, this implies y x must be negative in the interval 0 1, but if y-x is negative in 0 1, this will imply that gamma lies in the fourth quadrant. This is not true. So, therefore, dy dx is with negative sign. So, this is negative of minus 1 minus x square by x for x belonging to 0 1. This immediately gives that x times y prime is dy dx plus square root of 1 minus x square, this must be equal to 0. So, therefore, option B is correct and option D is incorrect. So, we got B is correct. Now, we have to see whether A or C is correct or not. So, now we have dy dx is equal to minus square root of 1 minus x square by x. So, by integrating we get y is equal to minus integral of square root of 1 minus x square by x dx, and this integral is easy to evaluate. So, what we can do is we can put x equal to sin theta, then dx is cos theta d theta, and square root of 1 minus x square will be equal to cos theta. So, this y is equal to minus integral cos theta by sin theta into dx is cos theta d theta. So, that is equal to minus of cos square theta, which is sin square theta minus 1 by sin theta d theta. So, that is equal to integral of sin theta d theta minus integral cosec theta d theta, which is equal to minus cos theta plus log of mod cosec theta plus cot theta plus an arbitrary constant c. So, now if we put sin theta is equal to x, cos theta is square root of 1 minus x square, this will give, this implies y is equal to minus square root of 1 minus x square plus log of 1 plus square root of 1 minus x square by x plus c. We do not need to put the modulus sign because x is positive, and since y at 1 is equal to 0. So, this will imply c is equal to 0. So, therefore, y is equal to minus square root of 1 minus x square plus log 1 plus square root of 1 minus x square by x. So, if we go back to the options, then we see that option A is correct and option C is incorrect. So, note that in this problem getting the differential equation was not difficult and also integration was not difficult. The only tricky part was to notice that only one of the signs of dy dx is possible. If you are not careful about that, then you might think that all the options are correct. So, let us move to question number 3. A solution curve of the differential equation x square plus xy plus 4x plus 2y plus 4 dy dx equal to y square for x greater than 0 passes through the point 1, 3. Then the solution curve A intersects y equal to x plus 2 at exactly one point, B intersects y equal to x plus 2 at exactly 2 points, C intersects y equal to x plus 2 square, D does not intersect y equal to x plus 3 square. So, first we have to solve this differential equation. So, we are given that dy dx equal to y square by x square plus xy plus 4x plus 2y plus 4. Now, if you notice, the denominator can be factorized as we have x square plus 4x plus 4 is x plus 2 whole square plus xy plus 2y, that is y times x plus 2. So, this is y square divided by x plus 2 times x plus 2 plus y. So, now we see that this dy dx equal to this some function of x plus 2 and y. So, this can be written as just like we do for homogeneous equation. So, this can be written as y by x plus 2 square divided by 1 plus y by x plus 2. So, now to solve this, we can put y is equal to u times x plus 2. This will imply dy dx is u plus x plus 2 times du dx, and therefore, we have u plus x plus 2 du dx is equal to u square by 1 plus u. So, this implies x plus 2 du dx is equal to u square by 1 plus u minus u, which is equal to minus u by 1 plus u. So, now we can separate the variable u and x. So, this can be written as 1 plus u by u du equal to minus 1 by x plus 2 dx. Then we integrate both sides. This implies 1 by u du will give log mod u plus u by u is 1 du. So, that is u equal to minus log mod x plus 2 plus c. So, this implies we can bring this log this side and we get log of mod u times x plus 2 plus u equal to constant. Now, we know that u times x plus 2 is y. So, this implies log of mod y plus u is y by x plus 2 equal to c. Also, we are given that this curve passes through the point 1 comma 3. So, y at 1 is equal to 3. This implies log 3 plus 3 by 1 plus 2 equal to c, which implies c is equal to 1 plus log 3. So, the solution curve is given by log mod y plus y by x plus 2 equal to 1 plus log 3. So, this is the equation of the solution curve. Now, let us look at the options. So, the first option is asking whether y equal to x plus 2 intersects this curve, and if so, then at how many points. So, putting y equal to x plus 2, we get log mod x plus 2 plus 1 equal to 1 plus log 3, which implies log of mod x plus 2 equal to log 3. And since x is greater than 0, we can simply write log of x plus 2 equal to log 3. And the only x for which this happens is x plus 2 equal to 3, that is x equal to 1. So, therefore, we have that the solution curve intersects y equal to x plus 2 at exactly 1 point. So, A is correct and B is wrong. Now, we have to see whether it intersects the curve y equal to x plus 2 square or not. So, putting y equal to x plus 2 square in, let us call this equation star, we get log y. So, log of x plus 2 square plus y by x plus 2. So, x plus 2 square by x plus 2 equal to 1 plus log 3, which is same as 2 log x plus 2 plus x plus 2 equal to 1 plus log 3. So, we have to see whether there exists any x for which this happens or not. So, for any x greater than 0, this left hand side is greater than x plus 2 will be bigger than 2 and 2 log x plus 2 will be bigger than 2 log 2, or 2 plus 2 log 2 is same as 2 plus log 4, which clearly is bigger than 1 plus log 3. So, therefore, LHS is not equal to RHS for every x greater than 0. So, therefore, the curve does not intersect y equal to x plus 2 square. So, option C is wrong. Now, we have to see whether it intersects the curve y equal to x plus 3 square. Now, putting y equal to x plus 3 square in star, we get log of x plus 3 square plus x plus 3 square divided by x plus 2 equal to 1 plus log 3. That is 2 log x plus 3 plus x plus 3 square by x plus 2 equal to 1 plus log 3. Now, again, since x is bigger than 0, 2 log x plus 3 plus x plus 3 square by x plus 2, this will be bigger than, the first term is bigger than 2 log 3 and x plus 3 square by x plus 2 is clearly bigger than 1, because x plus 3 is bigger than x plus 2. So, again, therefore, this is not possible. Does not hold for any x bigger than 0. Therefore, the solution curve does not intersect y equal to x plus 3 square. So, that means that option D is correct. Okay, now let us move to question number 4. Let a solution y equal to y of x of the differential equation x times square root of x square minus 1 dy minus y times square root of y square minus 1 dx equal to 0 satisfy y at 2 is equal to 2 by root 3. Now, consider two statements. One is y x is equal to secant inverse x minus pi by 6, and second statement is y x is given by one by y is equal to 2 root 3 by x minus square root of 1 minus 1 by x square. Then we have 4 options, both 1 and 2 are true. B, 1 is true but 2 is false. C is 1 is false but 2 is true, and D option is both the statements 1 and 2 are false. So, we are given some first order ordinary differential equation with initial condition y at 2 is equal to 2 by root 3, and then we have to see which one can be a solution to that. So, first thing, of course, you can try and see by putting x equal to 2 whether you are getting y equal to 2 by root 3 or not. If you try that, then you will see that both these statements satisfy that initial condition y of 2 equal to 2 by root 3. So, that does not help. So, we will try to solve the differential equation and see what solutions we are getting. Solution, what we are given is dy by y times square root of y square minus 1 is equal to dx divided by x times square root of x square minus 1. So, if you note that we know that the derivative d by dx of secant inverse x, this is equal to 1 by mod x times square root of x square minus 1. Now, here we have dx by x times square root of x square minus 1. So, if x is positive, then of course, the integral will be secant inverse x, but if x is negative, then we can just multiply the equation by negative 1 and we will still get. So, we do not have to worry about that, and by integrating we get secant inverse of y is equal to secant inverse of x plus constant c. Now, we will find the value of c by using the condition that y at 2 is equal to 2 by root 3. So, y at 2 is equal to 2 by root 3, this implies secant inverse of 2 by root 3 is equal to secant inverse of 2 plus c, which implies c is equal to secant inverse of 2 by root 3 will give pi by 6 and secant inverse of 2 is pi by 3. So, pi by 6 minus pi by 3, which is equal to minus pi by 6. So, therefore, we get secant inverse of y is equal to secant inverse x minus pi by 6, which implies y is equal to secant of secant inverse x minus pi by 6. So, we see that the statement 1 is true. Now, we have to see whether statement 2 is true or false. So, in statement 2 we are given 1 by y. So, if we see, we know y is equal to secant of secant inverse of x minus pi by 6, this is correct. So, this will imply 1 by y is equal to cos of secant inverse x minus pi by 6, and then by using the formula for cos of c minus d, we get this is cos of secant inverse x times cos of pi by 6 plus sine of secant inverse x times sine pi by 6, which is equal to cos of secant inverse x will be 1 by x and cos pi by 6 is root 3 by 2 plus sine of secant inverse x is square root of 1 minus 1 by x square times sin pi by 6 will be equal to half. So, you can put secant inverse x is equal to theta, that will mean x is equal to secant of theta. So, cos theta will be equal to 1 by x, and then sin theta is square root of 1 minus cos square theta. So, this gives this, and this is equal to root 3 by 2 x plus 1 by 2 square root of 1 minus 1 by x square. So, this is our 1 by y. Now, if you see the option, we are given 1 by y is equal to 2 times root 3 by x minus square root of 1 minus 1 by x square. So, that is not correct. So, what we get is that statement 1 is true, but statement 2 is false. So, B is the correct choice. So, now let us move to question number 5. Let y(x) be a solution of the differential equation one plus e to the x y prime plus y e to the x equal to 1. If y0 is equal to 2, then a y at minus 4 is equal to 0, b y at minus 2 is equal to 0, c y(x) has a critical point, in the interval minus 1 comma 0, and d y(x) has no critical point in minus 1 comma 0. So, first we will solve this differential equation. So, 1 plus e to the x y prime plus y e to the x equal to 1, the derivative d by dx of 1 plus e to the x times y. So, this gives 1 plus e to the x times y prime plus y times derivative of 1 plus e to the x is e to the x, and this implies 1 plus e to the x times y equal to x plus c. Of course, this you could have also seen that this is a linear first order ODE, then you could find the integrating factor and do it, but sometime it is easier if you can just realize this as the total derivative of some function. So, this implies y is equal to x plus c divided by 1 plus e to the x. Now, given y0 equal to 2, so this implies 2 is equal to c divided by 2. So, this implies c is equal to 4. Therefore, y is equal to x plus 4 divided by 1 plus e to the x. So, by putting x equal to minus 4, this implies y at minus 4 is equal to 0, and y at minus 2 will be equal to 2 by 1 plus e to the minus 2, which is strictly greater than 0. So, therefore, option A is correct and B is wrong. So, we got A is correct and B is wrong. Now, C and D are asking whether y(x) has any critical point in the interval minus 1 to 0. So, remember that critical point is a point where the derivative of the function is 0. So, y x is equal to x plus 4 divided by 1 plus e to the x. This implies y dash x is equal to 1 plus e to the x times the derivative of x plus 4 is 1 minus x plus 4 times derivative of the denominator is e to the x divided by 1 plus e to the x square. So, y prime x is given by this expression. This is equal to 0 at any point in the interval minus 1 to 0 or not. So, let us calculate what is y prime at 0. So, if I put x equal to 0, then 1 plus e to the 0 is 1. So, this is 2 minus 4, e to the 0 is 1 by 2 square. So, that is minus 2 by 4 minus half, which is less than 0, and y prime at minus 1 is equal to 1 plus e to the minus 1 minus 3 e to the minus 1 divided by 1 plus e to the minus 1 square. So, we just have to see what is the sign of this. So, this is equal to 1 minus 2 by e divided by 1 plus e inverse square, which is e minus 2 by e times 1 plus 1 by e square. Now, we know that e is bigger than 2. So, this is greater than 0. So, y prime at minus 1 is bigger than 0 and y prime at 0 is less than 0. So, by the intermediate value theorem, y prime x is equal to 0 for some x belonging to minus 1 to 0, which means that is y x has a critical point in the interval minus 1 0. So, option C is correct and D is wrong. So, A and C are the correct options. Okay, let us move to question number 6. Suppose we are given f of x plus y is equal to f x times f prime y plus f prime x times f y for all x y in R, and f at 0 is equal to 1, then find the value of log f of 4. So, we are given that f is a differentiable function which satisfies f of x plus y equal to f x f prime y plus f prime x f y for all x y in the real line, and also we are given the value of f of 0. So, if we put x equal to 0, y equal to 0, then we see that we can calculate the value of f prime 0. So, this implies left hand side is f of 0 is equal to f 0 f prime 0 plus f prime 0 f 0, that is 2 times f0 f prime 0, which implies f0 is given to be 1 equal to 2 f prime 0. So, f prime 0 has to be equal to 1 by 2. So, this is one fact that we derive. Now, we have to calculate the value of log of f of 4. So, we will try to find what is f of x. So, again putting y equal to 0 in the given equation, we get f of x plus y will become f of x equal to f x times f prime 0 plus f prime x times f of 0. Now, we have already calculated the value of f prime 0. So, this is equal to f x times half plus f prime x times 1. F prime x is equal to half f x, and this implies f prime x by f x equal to half. By integrating, we get log f x is equal to x by 2 plus c. F at 0 equal to 1 implies c is equal to 0. So, therefore, log of f of x equal to x by 2. We have to calculate log of f of 4. So, this will be equal to 4 by 2, which is equal to 2. So, let us check that. This f x satisfies the given functional equation. So, we have log f x equal to x by 2, which implies f x is e to the power x by 2. Now, if f x is e to the x by 2, then what is f x plus y? This will be e to the power x plus y by 2, which is equal to e to the x by 2 times e to the y by 2. Also, what is f x f prime y plus f prime x f y? This is equal to f x is e to the x by 2 times f prime y will give half e to the y by 2 plus f prime x is half e to the x by 2 times e to the y by 2, which is equal to half plus half is 1 times e to the x by 2 times e to the y by 2. So, therefore, this is true. Let us do one more problem. The differential equation dy dx equal to square root of 1 minus y square by y determines a family of circles with option A is variable radii and a fixed center at the point 0, 1. Option B is variable radii and a fixed center at 0, -1. C is fixed radius 1 and variable centers along the x axis, and D is fixed radius 1 and variable centers along the y axis. So, we know that the differential equation, when we solve, we will get a family of curves, and we have to choose the option among the given options. So, we have dy dx equal to square root of 1 minus y square by y. This is variable separable, ODE. So, we can write this as y by square root of 1 minus y square dy equal to integral dx, and this is easy to integrate. So, we put 1 minus y square as u square, which implies minus 2y dy equal to 2u du. So, y dy is minus u du. So, integral of y by square root of 1 minus y square dy is equal to integral minus u du divided by square root of 1 minus y square is u. So, this is minus u plus c, which means minus square root of 1 minus y square plus c. So, we get x is equal to minus square root of 1 minus y square plus c. So, this can be written as square root of 1 minus y square is equal to c minus x, which implies 1 minus y square is c minus x square, or I can write this as x minus c square also. This implies x minus c square plus y square equal to 1, where c is an arbitrary constant. So, this we see that this is gives a circle with center at c comma 0 and radius 1. So, the radius for all of these circles is fixed 1 and center is c comma 0, this lies on the x axis. So, therefore, option C is the only correct option here. A, B and D are wrong. Alright, so this finishes lecture 6 on integral calculus. Thank you very much.